So let me see today, Unit 3, Chapter 1. The main goal of this unit is focus on design part. This entire unit is a big unit, and rest of the concepts which we are going to be executing in the lab, it deals with this unit only. Okay, so this unit consisting of three parts. The first part talks about the architectural design. The second part talks about the UML diagrams. The third part talks about the process and product metrics. So these three categories of concepts we have. The first two are as integrated into one. That is architectural design as well as unified modeling language diagrams. Okay, let me see the part of this how we can create with the help of the requirement models which we discussed in the second unit, how we are going to be converting or translating requirement model into architectural models will let me see in this unit. Let me start with the chapter 1 will deals with two parts, as I said you. One will deals with the architectural design and the second part deals with the UML diagrams, right? So in this creating an architectural design, as per the syllabus, the bold is your topics, design concepts, software architecture, architectural styles and patterns. But as a knowledge or as a some of the content which you require to understand the design concept or software architecture or architectural styles and patterns, I'm also just give a touch to you on the topics design process and design quality. Okay, and also we have another topic design data design and architectural design. So which one are bolded? The three topics are your syllabus. The other which is not bolded, it is not is a part of your syllabus. No question will comes into that three topics, but it will be required to understand this concept. So bold only your syllabus, in that only the questions will comes. Let me start with a prerequisite of every chapter. This is requirement engineering. The unit 2 talks about the requirement engineering. This talks about the design engineering. Now let me have see the first the definition of software design. In this definition of software design, if you observe carefully here, the software design encompasses some set of principles, concepts and practices that deal to the development of a high quality system or a product. So the input for design is we are giving some set of principles, concepts and practices. The output we are getting is a quality of product or a quality of high system, right? So it encompasses is integrated with these three. So some principles already we have studied in the previous chapter, and we have also seen some practices, and we required some concepts over also to make a high quality system or high quality product. Has part from the Mitch Kapor in 1990 said that the definition of design is in total it will be put in the two worlds. That is, the first world is technology. There is the first word. The second word is the human purpose. So if you are going to be integrate this human purposes and technology into one, if you integrated this now, integrate in the sense combine into this parts, if it is a this is a world, if you make this technology and human purpose as a single, then that is the exact definition of design. So the world of technology and the world of people and the human purposes, you are trying to bring together two together, two together. If you bring that together, then it is a design. So we need to make a bridge between the technology and the human purposes. That bridge, how good you can design, that will connect closer to their requirements. And coming to the Roman architecture of this, it is how deals with, like we can say, these are the three main characteristics of a design as per the Roman architecture. The first part of this is firmness. The first characteristics over in the design, firmness. The second, commodity and delight. Firmness in the sense, whatever the program you are developing, it doesn't need it or doesn't consisting any errors or bugs. Bugs in the sense errors. Commodity is saying that whatever your program is developing, it should be suitable for to fulfill that purpose. For example, if you develop a program for prime number, it does not gives the output as the odd numbers, printing the odd numbers over there. The program you're developing for prime numbers has to give the for prime numbers only. It doesn't give the output as Fibonacci series. So commodity talks about whatever the program you are developing that has suitable the fulfill needs or the purposes which you are going to be intended for. And delight, the third characteristic is delight. Delight talks about what the program you have does, it should be give some pleasurable one, in the sense it gives some sort of friendliness, and it supports for ecosystem, right? So these are the main three characteristics of any design: firmness, which talks about without any errors; commodity, should be suitable; delight, it gives some experience or a pleasure for that. And this is a very important slide. If you observe carefully, the main goal of the design, why we are using this software, is to produce a model. As I said you, the output of a design will give a high quality system in the form of a model or representation of all the three characteristics. Just a simple just representation of all three characteristics we can talk over there. The three characteristics, whatever just now we have discussed, firmness, commodity, and delight, that three will deals with this one. Okay. And if you are see that design model provides detail about the software architecture, the total details it will gives the architecture over here. The total provides details in the sense in details the total information for developing an software architecture. So we can say a design model can consisting of the software architecture, interfaces over there, and components. With the help of these three, we are going to be implementing in the next phase. The next phase of design is what? Construction or deployment, or sorry, development or implementation. So with the help of this software architecture, interfaces, components, which is provided by the design model, we are going to be implementing as per that. And the main focus of design is quality. And like OS, or we can say a kernel is the heart for a computer, in the same fashion, design sets for the software engineering phases, it will be like a kernel. Design sets the stage for construction. The input for construction is what? Design. So whatever you are giving that design part, it will be the input for construction. So the main goal of design is to produce a model or just a representation of all the three characteristics: firmness, commodity, or delight. And it gives the details of the software architecture, interfaces, some components which will be helpful for in the implementation of the next part. If you see this scenario, hope you remember the requirement models we have, like scenario based, already we have discussed this, flow oriented, class oriented, behavioral elements. This part of this for a specific, if you we have discussed in data flow diagrams, right? So in that process we have scenario based elements are there, flow oriented elements are there, class based elements are there, behavioral elements are there. All these are connected with the help of analysis model. If you observe carefully here, the analysis model, which is we discussed in the previous topic, it is making connectivity of all these elements. Now if you see here, has a this is a triangle of this in the diamond shape, that is a design model. So this is an analysis model here, and this is design model. Both are going to be connecting. How they are going to be connecting? Analysis model elements are there, and here we have different designs are there. Like we have data or class design, we have architectural design, we have interface design, we have component level design. Like this, different designs are there. So whatever the design you like to be, it will be converted the requirement models into design model. But when you are converting which type of requirement elements, you are converting into which type of design. It is not simply scenario based elements will be converted into interface design. It is not simply like that. So based on the element, it will convert the respective design over there. If you see the figure carefully, in the bottom up data and class diagram, that is class design, will be talks about from class based elements, where how we can be design that with the help of the class diagrams, with the help of analysis package, with the help of the CRC models. Already we have seen this one. and collaboration diagram. So with the help of this three, four, we are going to make the design and class designs, data and class design. If you want the architectural design, we are depending on the flow oriented elements like data flow diagrams, the control flow diagrams, processing narratives. With the help of this, we are making architectural design. If you talk about the third one, interface design, if you talk about the third one, interface design, it is coming from the flow oriented as well as it is coming from scenario based elements. For the both, it is coming over this. If you see the fourth one, component level design, the fourth part of this, it will coming from flow oriented elements as well as from the class based elements. It is coming from the again one, two, again is a behavioral elements. So you can convert a class based elements into a component level. We can convert a behavioral elements into component level design. We can convert a flow oriented elements into component level design. So this diagram clearly shows when you want to be convert a scenario based element into an interface design, you can use a use case text, or you can use a use case diagram, or you can use the activity diagram, or you can use the simline diagram. With the help of that diagrams, we can convert a requirement elements into a design elements, or a requirement model into design model. So the bottom of in this figure, for every figure here, we have this is here for they are giving as how we are going to be converting. That are the ways or solutions to convert a scenario based elements into respective design, to convert a flow oriented elements into respective design, to flow convert a class based elements into respective design, to convert from behavioral elements to respective design. So in this second field, it is a, talking about the solutions for that. While coming to the design process, like we have the software process, here also we have design process. So coming to the definition, another definition of software design is an iterative process through which requirements are translated into blueprint. Just now we have seen the figure. Requirement models into design model means it is an iterative process which can convert the requirements into a model, into a design, or into a blueprint. For what purpose? For constructing the software. So that is another definition of software design, right? So software design is an iterative process through which requirements are translated into a blueprint for the construction of software, right? So initially, whatever the blueprints, it depicts a holistic view of a software. By seeing that design, we can come to know how it will be look like. And very important slide over here, that is quality. So the output of the design is what? High quality system or high quality product. Now, how you can measure whether whatever the output is given by the design model is correctly meet the requirement, meet the thing, is with the help of some software quality guidelines and attributes. So we have in this slide, we are talking about the software quality guidelines as well as software attributes. Let us talk first the quality guidelines. To make this quality guidelines, uses recognizable, we have architecture styles and patterns. In upcoming topics, we have separate topic, architectural styles and patterns. With the help of architectural styles and patterns, we can recognizable whether a particular quality is meeting the requirement or not. Modular, we are dividing the total program into different partitions or different modules. Now each module, how you are going to representing is with the help of data, architecture, interfaces, and components. With the help of this distinct representation of data, architecture, interfaces, and components, we are making sure whether the quality is met or not. And we have to see such a way that what are the appropriate data structures they are going to using to implement the classes. And we have to see that independent functional characteristics for components is there or not. And we have to see interfaces whether correctly connecting to each other or not. And we have to reduce the complexity of that interfaces, because interface will play a vital role to convert from one environment to into another environment. So finally, a design should be represented using a notation that effectively communicates its meaning. So notation in the sense, the graphical representation what you are going to conveying is very important. So notations will be play a vital role in the design. If you are using just a simple notation, it is not that much of a way of uh, attracting where we can conclude our what the product will look like, right? So these are the few quality guidelines, like we had to make sure the artificial styles and patterns are going to be with the help of that we had to measure whether the quality has meet or not, and the modality, and we had to make sure whether distinct representation is there for the data architecture interfaces components, as well as the appropriate data structures are going to using or not, and how independent functionality characteristics for components will be there. And also we had to see we need to reduce the complexity of the interfaces, and finally we had to see the notations is correctly properly effectively communicating in the design or not. And coming to the quality, that is software qualities, this very important slide. Quality attributes, or we can say software qualities. Software quality also be called as software attributes, also called as quality. So software attributes also be called as the quality. Simply quality. So a quality of attributes consisting of verbs, FU or PS, where F stands for functionality, U stands for usability, R stands for reliability, P stands for performance, and S stands for supportability. If you observe carefully here, this verbs, as I said you in the previous topics, LETs in the sense it ends with ILIA, LETs, ILITIES, LETs you can ends with them. Functionality which can sets and capable, the features of feature set and capabilities of programs, and we have to take care the overall security of the system. Usability talks about the user friendliness is how much it is there, and any aesthetics will be there, or any consistency over here, consistency, and as well as the documentation part. And coming to the reliability, how we are measuring is with the help of MTTF. This is a metric, mean time to failure. We'll talk about in the metrics concept. By evaluating the measurement, the frequency and severity of failure with the help of MTTF metric, mean time to failure, we are check whether how much reliable your product or system is doing. And performance we can calculate with the help of speed, time, the resources you are going to using, and also the throughput and efficiency. With the help of all these metrics, or we can say measures, we can calculate this performance metric, or we can say these are the metrics you are going to using to calculate the measurement of performance. And supportability, which extend, which going to be elaborated, extendability, adaptability, serviceability. If these three will be satisfied, automatically supportability will be satisfied. If you observe carefully, this verbs talks about the software qualities. Software qualities also called as simply software attributes. Software attributes also called as quality. So software attributes or quality of a software is functionalities, usability, reliability, performance, supportability. Simply it is a FUBS if you observe carefully, right? So if you see the evolution of software design from the last 6 decades, in 1971, in 1971, it talks about 1971, it is dealing with, if you see in the 1971, it called as top-down manner. In 72, it called as structured program. In 74, 75 around, instead of that structured programming, they are going to adding as little bit of the data structures where we can consider as not purely object oriented, that's partially object oriented. In 1992, it will be the evaluation goes to object oriented approaches. The evaluation goes to object oriented approaches. Next, in 2006, they'll make as software architecture. After that, in a few of that, accept oriented methods, and after that, the model driven development. Like this, the evaluation is coming from how good we can represent, from top down manner to structured programming to data structures or partial object oriented, and again purely object oriented approaches, again software architecture, again expert oriented methods, again model driven. So in the brackets, it is giving the who are the authors and even each year, which year it is proposed. But as part of this is only I want to convey you how the evaluation is goes on from the last 6 decades. So last 6 decades in the sense each decade is a 10 years, right? So how it is the evaluation is going. So in this conclusion of the topic, what we have studied is the definition of software design, followed by the design definition, followed by the characteristics of a design, followed by the main goal of the design, followed by how we are going to be translating requirement model into design model with the graphical representation, followed by another definition for software design and quality guidelines and qualities, that is software attributes, followed by the evaluation of software design. So that's about the introduction part for this design engineering.